Good afternoon, friends. After Janmashtami holidays, this was the first lecture in microbiology subject. Myself, Kunal Upadhyay, Assistant Professor from Gyan Yagna College of Science and Management, Rajkot, and with me my colleague Rana Archana. She is Assistant Professor from M.Ed. and Virani Science College, Rajkot, in microbiology subject. Today our topic is biological treatment of wastewater. This is very related topic to current season, that is monsoon, because water pollution and water contamination is very frequent problem in this season, and that's why so many waterborne diseases are also very frequent in this season. So how can we overcome such problem, and what microbiology can do in this era or in this side, that we shall discuss in this topic, that is biological treatment of wastewater. Water is the most essential thing for all types of life form. Without water, nobody can even imagine any civilization, any life, or anything else. And this water is normally getting polluted or contaminated every day by so many anthropogenic, that means human based activities. So it's important to recycle the water and to save the water for future purpose. Otherwise, water may not be remain available for future generation, because we know that the water sources are very much scarce, and we are having population problem very much severe. So this is one of the very important thing, to recycle water and to save water for some other purposes. Now, what is exactly the meaning of word wastewater? What you can say wastewater? Wastewater is nothing but, actually it is used water. Means the water which is already has been used for some other purpose, that water is known as wastewater. It may be of basically two types. One which is generated from domestic waste, which is generated from human and animal excreta, and water which is used from washing, bathing, cooking, or any other household activities. And usually such wastewater is called sewage. Sewage is usually generated from domestic waste. While second type of wastewater is called dairy or industrial waste, which is generated from some dairy or some industries like slaughterhouse waste, dairy waste, confectionery waste, or even paper mill waste, or alcohol based industry waste. All these waters are known as dairy or industrial waste, which are also known as effluent. Effluent is generated from industry, while sewage is generated from domestic purpose. Usually in domestic waste, mostly 100 to 500 gram of feces and urine and all these things are present in domestic wastewater, while the BOD value of this thing is usually 15 to 20 gram per day. It is contributed by each person in wastewater. This is the major composition of domestic wastewater, which is called sewage. Major component of domestic wastewater is COD value, that is called chemical oxygen demand. That is very much important chemical criteria, chemical parameter to know the strength of wastewater. Here it is value is ranging from 250 to 1000 milligram per liter. Total nitrogen content is almost found 20 to 90 milligram per liter, while total phosphorus content is usually found between 4 to 15 milligram per liter. And these things are every day they are added in wastewater, and water is getting polluted and contaminated. These are the few figures or data for industrial wastewater. Here we have taken the example of starch based industries or potato based industry and their wastewater. Their major component COD is usually found very high, and it is 10,000 to 20,000 milligram per liter. And due to this thing, every day 20 meter cube per ton of starch is added. High COD value, high suspended solid, and cyanide may also be found in such wastewater. So usually it is found that sewage is less harmful as compared to effluent, because effluent is mostly contains some hazardous chemicals, some heavy metals or some other pollutants which may cause some problem to aquatic system or even for some human or any other animal whoever will consume the same water. Now, basically wastewater treatments may be of two types. One is known as single dwelling unit. Good example is of septic tank, and another one is municipal wastewater treatment, which is carried out at large level, which is carried out by municipal corporations, and they are having their own sewage treatment plant, and every day million liters or million gallons of water is processed in such plant. Septic tank. Septic tank is very common in society, communities, shopping center, malls, or any other localities. Even single household is also having the same septic tank. It is the simplest form of biological wastewater treatment. Usually here process is carried out anaerobically, and this anaerobically whatever process is carried out, here methane is the main product which is generated during this process. The main aim of septic tank is to remove suspended solid matters from the wastewater. Now this suspended solid matters can be removed in two ways. Either it is removed as a scum. Scum is the uppermost or surface part at where some light suspended solid particles are usually getting separated, while other way to separate such suspended solids are as a sedimented solids, and these sedimented solids are usually found at the bottom part of such tank. So this is one diagrammatic representation of same septic tank, in which from one side a sample is entered and it is processed inside the tank, and liquid solid, these two parts are separated, and liquid part is going further for from outlet, while solid part is separated out from other side of the septic tank, and later on this water has been discharged in other distribution channel by the pipelines which are known as sewerage. Sewerage is the pipeline which are used for the same purpose. Now initially it was considered that whatever wastewater is generated, that we can simply dump in any water body, say for example in ocean or in river or any pond or any water stream which can take the wastewater, and it was considered that dilution is the solution of any water pollution, but now we know that it is not true. So dilution is not the solution of pollution. So we cannot now remain dependent on this technique. So that's why we are having this municipal wastewater treatment with us, and this is the overview of entire municipal wastewater treatment, which is entirely divided in four parts. First one is physical process or primary treatment, which is based on physical parameters. Second one is known as secondary treatment, or which is based on biological parameters. Third one is known as tertiary treatment, which is based on chemical parameters, or it is also known as advanced treatment. And the fourth one is the thing which is generated as a waste from each of this stage, which is called sludge, and their solid processing is considered as the fourth stage of municipal wastewater treatment. This is one aerial overview of our Rajkot wastewater treatment plant, where all these facilities can be seen, and this we shall take now one by one in a little bit detail in next slides. This is very first step in any wastewater treatment. It is called physical treatment or curse solids removal or bar screen. Here whatever curse solids which are found in the wastewater, say for example bottles, plastics, even sometimes tires may also surprisingly found in such wastewater, and they are also separated by this bar screen, and later on this separated waste has been transferred to either landfilling or incineration, and in this way it is removed. This is second one. After bar screening, the next step will come, that is flow measurement. Means water which is received at sewage treatment plant, okay, whatever flow is coming, that flow can be measured by this device which is called partial flum. The partial flum is having some characteristic dimension, and in some particular period of time, how much water is passing from that much area, it is known as partial flum or flow measurement. There are two types of flows are found in wastewater treatment plant. One is known as peak flow and one is known as lymph flow. Peak flow is the one which is received during most of the day time of the human activities. Means it is considered that between 6 a.m. to 11 a.m. is the peak flow of, or is the peak time for wastewater generation, while remaining time is considered as a lymph time for wastewater generation. So water which is coming to this part, it is not the same. Some different waters, level of waters are coming. Second step is coming, that is called grit chamber. After removal of cursed solid particle, here grit part. Grit means actually some soil or sand or silt or whatever things are coming from coming along with wastewater. They are separated from this part of the wastewater treatment, which is called grit chamber. After grit chamber, this is third thing is coming, that is called sedimentation tank or settling tank. Here the general aim of this process is to remove oil or grease part from the sludge, as well as whatever solid particles are still remain in the sludge, they are also removed out from this step of the sludge digestion or wastewater treatment. Here it is having two parts. Upper part is usually doing the skimming, or it is also known as scum remover or skimmer. Okay, it removes upper grease or oil or detergent or whatever things are coming in the wastewater. It is removed by upper one, while lower one is usually scrapping whatever sludge or whatever solid things is getting deposited at the bottom part of this tank. And after that, from here, water has been channelized for next step, which is called secondary treatment. Usually water spend 12 to 14 hours in this settling tank, which is called sedimentation tank, which is called oil removal tank, or it is also known as primary settling tank. Now water is coming for second one, that is called secondary treatment of wastewater. These are various processes by which water can be treated. Actually, these are not the sequence, these are the types. Okay, so either one or two or as many as possible, if they are present, then it will be helpful for treatment of wastewater. So trickling filter, activated sludge process, oxidation ponds, forced aeration process, and aim of tank. Main aim of secondary treatment or biological treatment is to remove dissolved solids, or to remove to reduce BOD value. BOD value means biochemical oxygen demand of wastewater. This biochemical oxygen demand of wastewater can be lowered down, it can be decreased by secondary treatment only. The second thing which can be removed from the sludge by biological treatment, it is the capturing of suspended or non-settleable colloidal solids which are not removed in the previous step of the wastewater treatment. Means during primary step of the wastewater treatment, they are removed out from wastewater in the form of floc or biofilm by microorganism during the secondary treatment of wastewater. Later on, the third thing which can be removed from water during biological treatment, it is to remove nutrients like nitrogen and phosphorus. In other words, we can say that by biological treatment, we are trying to reduce nutritional load of any wastewater or any water, because if nutritional values or nutritional load is removed, then water will not be further contaminated by any other contaminants, and water will be safe. And the last and final one is to remove specific trace organic or inorganic compounds, whatever are left during physical process. They can be removed safely, they can be removed easily by biological treatment or by secondary treatment of wastewater. Even we can remove TOC, that is called total organic carbon, by secondary treatment of wastewater. So we can say that biological treatment or secondary treatment, it remains at the heart of entire wastewater treatment or sewage treatment process at whatever level it is used. Very first thing is coming, it is called trickling filter. Trickling filter is a very simple process. Here generally 8 to 12 feet long bed of rock is prepared, and sewage or whatever water which is coming from primary treatment, that water is sprayed on this bed of the rock from the top of the bed by rotating sprinkler. There is one rotating sprinkler is there. We can see this sprinkler in this diagram here. This sprinkler constantly sprinkle the flow of wastewater over this bed, and now water is simply trickling down to the bottom side, and when it is trickled down, it will react with bed of rock and it will get clarified. Here one more thing is formed, it is called Zuglial film. Zuglial film is nothing but it is prepared on the surface of rocks, and heterotrophic extracellular polysaccharide producing microbes are usually found in this area, and they adhere on the surface of rock and they make one layer. This layer is called Zuglial film. Zuglia word is actually coming from Greek word. It is having the meaning zoo, like living, and glia means glue. So in short we can say that it is living glue which is adhere, which is stick over the surface of rocks, and we can say that now microorganisms are immobilized on the surface of rock, and whatever wastewater is coming, that wastewater will be used as a medium. It is used as a nutrition medium, and microorganisms will grow and multiply by using this medium, and they will make utilization of complex organic compound, and they convert them to simple inorganic minerals. Here a prolonged activity of this Zuglial film will make anaerobic condition in microenvironment of rock, and that will leads to favorable condition for the growth of anaerobic organism. So we can say that here heterotrophic organisms are facilitating the life or facilitating the growth of anaerobic organisms. So it is very good example of actually commensalism which is found on these rocks. This is the diagram of the same trickling filter. Here from bottom side the pipes are shown, it is known as sewer pipes, and via sewer pipes water is usually collected and then it is slowly sprinkled over the surface by rotating sprinkler, and water is getting trickled down through bed of rock and it is get clarified. This is the second step or second type of biological treatment of wastewater. It is known as activated sludge process. Before going in any detail, we will clarify what is sludge. Sludge is nothing but it is solid or semi-solid mud-like part which is acted upon by microbes and contains actively growing culture of microbes. So sludge is partially degraded and it contains a very young culture of microorganisms, actively growing culture of microorganisms. So it is a highly fertile, highly it is used as a fertilizer for in agricultural practices also. In this treatment usually sludge is recycled and then it is re-inoculated in fresh sewage which is coming from primary treatment, and by this way we can reduce the rate of decomposition, we can enhance the rate of decomposition and we can reduce the time for treatment. This is the diagrammatic representation of activated sludge process. Here primary effluent is coming. Primary effluent means the water which has already been treated in primary treatment and now it is coming here. It is also known as influent or effluent. Both words are used, primary effluent or influent. This influent is added in first aeration tank. Aeration tank is the device at where fresh air is also added by air compressor, and it is also cause the aeration of fresh sewage, and then it is channelized for final clarifier. Final clarifier is also known as secondary sedimentation tank or secondary settling tank. The reason is that once settling tank or sedimentation tank has already been used during primary treatment, during physical process, so that's why the same treatment is coming again. So that's why this secondary and primary, these two things are getting separated. In secondary treatment or secondary sedimentation tank, usually now microorganisms will act upon the fresh sewage and they will make sludge. This sludge has been recycled by recycle pump, and it is freshly inoculated in newly coming sewage, and in this way they will enhance the rate of reaction, they will decrease the time for the degradation, and we can make process faster by this process. So this is one of the most proved process in biological treatment of wastewater. This is the actual photograph of the same activated sludge process treatment. Now we are coming for third one, which is called oxidation pond. Oxidation pond is the simplest type of biological treatment or secondary treatment of wastewater. Here this is actually not any technologically sound or any modified process. It is very simple process. It is usually found in ponds, river, water streams, lakes, or whatever water bodies are there. This is very frequent process in all of these places. The advantages of oxidation ponds are like this: no electricity or no machinery are needed, so capital investment is very less. Only land cost is the cost to be considered during the planning of this oxidation pond. Usually no qualified manpower or even not at all manpowers are needed for oxidation pond, because it is very primitive technique. It doesn't require any technological sound persons or anything else. So these are the advantages of oxidation pond. This is the diagram of oxidation pond. Here the entire system has been divided in two parts, upper part and lower part. Upper part is known as photic zone. Photic zone of the water is the part of the water or is the area of the water up to which light can penetrate. Generally it is decided by how much turbidity is found in the water, and the turbidity is all due to how much suspended solid particles or suspended microorganisms are found in the water. So in photic zone usually algal growth is preferred, and algal growth is mostly found in this upper area of oxidation pond. We know that algae are very famous for their photosynthetic reactions, and they utilize light and CO2, and they produce some organic compound in oxidation pond. This dead algae and organic compound which are produced by algae, it will be shifted to benthic zone of the oxidation pond, and in benthic zone usually heterotrophic organisms or anaerobic organisms, they usually grow in that area, and they will utilize this thing, and they will make simplified, they will make clear water in the same oxidation pond. So it is actually one type of symbiotic relationship between algae and heterotrophic organism, because algae are fascinating the growth of heterotrophic organism by providing oxygen and organic matter, and heterotrophic organisms are providing carbon dioxide back to the algae, and both are benefiting in this reaction. The water, whatever time is spent by water in this tank, that time is known as HRT. In the language of water technology and all this thing, this time is known as HRT. HRT stands for hydraulic retention time, means how much time water is pending in particular treatment, that time is known as HRT for the water. HRT of the water may depend on several factors like quality of water, BOD value of the water, COD value of the water, TOC, nutritional load, how many organisms are present. All these things will decide how much time water should be kept in particular treatment of waste water. This is the same real diagram or real picture of oxidation pond in some wastewater treatment. Remaining portion will be continued by my companion lecturer Archana Rana madam.
Thank you. Now we have to discuss and we have to continue with the secondary treatment for the wastewater only. And in the secondary treatment of wastewater, we are discussing the oxidation pond. We have already discussed about the oxidation pond. Just the modification of oxidation pond is there, where not any type of aerator is involved. Here we have to discuss the one in which aerators are involved, and that is known as the forced aeration technique. So now we have to discuss about the forced aeration technique. You can see from the slide that forced aeration technique is the one in which just the modification of oxidation pond is there. And why this is there? To overcome the problem of reduced level of dissolved oxygen in water. So fresh dissolved oxygen is continuously being added by aerators, and in this current scenario even the biosensors are fitted with the aerators, and even sometimes the length of the aerators can be modified. So forced aeration method is the one by which the oxidation pond whatever works, just like that the dissolved oxygen maintenance can be possible, and that is one of the way of the secondary treatment of wastewater. The next one is the picture of the aerator. You can just see from the picture, the figure shows in the bottom the aerators are there. When these aerators are moving, they are rotating, at that time dissolved oxygen is going to be added, and that's why whatever the BOD maintenance is there, that can be there with the help of forced aeration. Next one, the same is there in this picture also. So this is one of the forced aeration technique for the secondary treatment of the wastewater. Next please. Now we are coming to the last treatment of the secondary treatment of wastewater. This is known as Imhoff tank. We have discussed about the septic tank, that is for the single dwelling unit. Just the little modification is there, that is known as Imhoff tank. What exactly the Imhoff tank? Why the name is Imhoff tank? Because the German engineer in the year 1876, the name was Karl Imhoff. They have designed this particular tank, and that's why the name is Imhoff tank. The modification of septic tank is there in such a way, the two problem is there with the septic tank that can be overcome by the Imhoff tank. You can just see from the picture, the figure is there, the schematic diagram is there, that shows the two different type of the compartment. One is settling compartment and another is sludge digestion compartment. One compartment is there that is having the slope type of the area from where the sludge is going to be collected in sludge digestion compartment, and then the sludge withdrawal line is there. So from there sludge is going to be withdrawn. So now in this tank there is no problem of the mixing of the sludge, while in the septic tank the mixing of the sludge was the problem. So next please. You can see the two disadvantages of the septic tank can be overcome here, that it prevents the solid that is removed from the sewage by mixing, and it provides the effluent amenable to further treatment. So that is the Imhoff tank. Now after the secondary treatment, what we have with us the effluent and we have with us the sludge. So whatever the effluent is there, if they require the advanced treatment, then we have to proceed for the advanced treatment. That is not always such that advanced treatment require at each and every stage in each and every type of the wastewater. This advanced treatment is even known as chemical treatment and even known as tertiary treatment. So what exactly the advanced treatment is? Advanced wastewater treatment is required when removal of substances beyond the primary and secondary treatment processes are necessary. So not always advanced treatment is required. The next one, it may be introduced at any stage of the total treatment. This statement is correct, but generally most of the time that is applied after the secondary treatment. So after the removal of the pollutant, the advanced treatment is applied. Advanced treatment may involve biological nitrification, denitrification, ultrafiltration, reverse osmosis, carbon adsorption, chemical addition, and ion exchange resins. We know very well in current scenario there are reverse osmosis, and that are the method that is used in routine life for the water purification purpose in day-to-day life. That is even used for the wastewater treatment, but as we know very well, the RO system and ultrafiltration, they have the high cost, and that's why this all the method that is listed in the slide, they all are having high cost, and that is the disadvantageous. So which are the methods that are widely useful by the industries? That are removal of suspended solids, coagulation, flocculation, chlorination, activated carbon treatment, nitrogen removal, phosphorus removal, and post aeration. Now removal of suspended solids, whatever the suspended solids are there, they are removed as it is from the wastewater by the float, and that's why the floating is the one of the method for the removal of the suspended solid. But coagulation and flocculation, what exactly the coagulation? By the negative charge containing particle, whatever the neutralization is being made, and by that the increase is there in the size of the particle, and as the increment is there in the size of the particle, they can easily removed from the wastewater. So that is the one method that is known as coagulation. Just like that the flocculation is there, flocculation in that the flocks of the different particles are being prepared and they can be easily removed. The next method is chlorination. We know very well the chlorine is one of the disinfecting agents. So this step is also known as disinfection. So what exactly the chlorination? Chlorination have two purposes. One is for the disinfection and the second is for the removal of bad odor. So with the help of chlorine, the bad odor can be removed. Now one point is that in this one here, application of the chlorine can be possible by two way. Either we can use the liquid or either we can go for the use of the gaseous. So that is the chlorination. Now the next is there, that is activated carbon treatment. In activated carbon treatment, whatever the chlorination is being there, because of the chlorination, extra chlorine is there that can be removed. As we know very well, worldwide absorbent that is very well known is activated carbon. So here the activated carbon is used as absorbent, and by that the absorption of the whatever remaining chlorine is there and another toxic substance, just like the pollutant, the dye, the non-degradable substance, they are absorbed and then they can be removed. Then nitrogen removal, phosphorus removal, and post aeration. These three are another step of the advanced treatment. In this, what exactly the nitrogen removal? We know very well what exactly the nitrogen is. The nitrogen is present in each and every organism also, and nitrogen is present in each and every component also. So in wastewater, whatever the debris are there, they are containing nitrogen in high amount. By the action of organism, this nitrogen can be even converted in ammonia and can be released, and even formation of N triple bond N, that we call it as nitrogen gas, and directly the nitrogen gas can be just be free in the environment by the action of anaerobic bacteria. So that is the nitrogen removal. We can see in the next slide that is showing the reaction that anaerobic microorganisms possesses different microbes that have the capability to convert nitrate and nitrite to nitrogen, and that escapes to the atmosphere. The next step is that in which phosphate removal is there. Now in the sludge, phosphate removal is possible by two ways. One is chemical treatment and another is biological treatment. Here whatever the step is shown, this particular equation that shows alumina, alum is mixed with the phosphate and aluminum phosphate can be removed from the sludge. This is chemical treatment, but we have to pay attention on the biological treatment. What is the biological treatment? We have discussed activated sludge before this oxidation point. What exactly the activated sludge? We are providing the particular area in which the organisms are being kept, they are growing, they are by the growth, they are increasing the particular level of the organic matter and they are removed. Just like that, the sludge is going to prepare. Just like that, in phosphate removal, what is that? The activated sludge pond are divided in two particular area. One area is there where anaerobic condition is provided. Because of the anaerobic condition, the organisms are not going to grow in that area as they are aerobic. So here anaerobic organisms are not going to grow, and because of that, the organisms, when they are collected to the aerobic area, so from the anaerobic to the aerobic area, when organisms are shifted, as they are shifting, they are going to produce their metabolites as fast as possible, and because of that, they will going to collect more and more amount of the phosphate that is present in the given area, and by that the consumption of it is going to be there, and because of the consumption of the phosphate, the biological phosphate removal is going to be there. So with the help of microorganism, just with the help of activated sludge, whatever the area is there, we have to just partition, we have to carry just partition of that area into two. One is anaerobic area and another is aerobic area. We have to grow an aerobic organism in anaerobic area, so they are not going to grow, and then we have to shift them to the aerobic area. So when they are shifted to the aerobic area, they will grow as fast as possible and they will consume more and more phosphate, whatever present in the wastewater, and by that we have to go for the collection of the microorganisms. So as and when the microorganisms are collected, 90% of the phosphate removal can be possible by the biological phosphate removal processes. So that is one of the best way to remove the phosphate from the wastewater, and then the process is there, the step is there, that is known as post aeration. So advanced treatment is there that have the removal of suspended solids, the activated carbon treatment, chlorination, nitrogen removal, phosphorus removal or phosphate removal. After this, whatever the dissolved oxygen is there, if that is going to be depleted, we have to go for the increase of the DO, and for that the method is there that is known as post aeration. So primary and secondary, even advanced treatment reduces the dissolved oxygen from the sewage, and thus to maintain it, post aeration is carried out. It can be accomplished by mechanical rotors and even by cascading slow technique. The next one. The picture shows the post aeration. The pond is there with the water that is passed from the advanced treatment, and now whatever the DO maintenance is there, that is going to be there in this particular effluent, and now this effluent is ready to landfill or land application or for the disposal. So next please. So now the disposal is there. So after all this treatment, the effluent is disposed out in various ways. The disposal into the surface water, the land application, and landfill can be there. Maybe there are the variety of the lakes are there in many of the cities. They have the effluent of the wastewater that is treated by the advanced treatment, that is treated by the secondary treatment, and from that the lakes are prepared. So lake preparation or pond preparation inside the city. There are many of the cities in the India are also there. They contain in the center of the city the particular lake, and that lake is full of this type of the water. That water is treated after the secondary treatment or after the advanced treatment. So now this is the case about the effluent. So next one. Now we have the sludge with us after the completion of secondary treatment and advanced treatment. Now what is there? After the wastewater treatment, primary, secondary and advanced treatment, one of the very most important step is known as solid processing. The sludge. We have already discussed the sludge. What is sludge? All the thing we know very well. The important step is there that is known as thickening of the sludge. This can be possible by gravity thickening. What exactly the gravity thickening? In which the water content is there that is going to be removed from the sludge, and the mass of the sludge is prepared in such a way that is ready to use for anaerobic sludge digestion, and that is very important process, that is biological process in which the thermophilic organisms are used. Dewatering of sludge is there and disposal of sludge is there. Finally, whatever sludge is prepared that we can use as a compost, that we have to discuss later on, but right now we have to concentrate on what exactly the anaerobic sludge digestion. So in the solid processing, the most important process or most important step is anaerobic sludge digestion. The word is anaerobic. So here no involvement of the oxygen is there. So bacteria, they are involved in this method, are known as anaerobic organism. The sludge, we know very well what is sludge. And digestion. The word digestion is there because microorganisms involved in this step, they are utilizing in condition that is anaerobic, and they are responsible for the digestion of organic matter. So anaerobic digestion is a series of process in which microorganisms break down biodegradable material in the absence of oxygen used for industrial or domestic purposes to manage the waste or to release the energy. So that is their metabolic process by which they are digesting the particular biodegradable material. Next one. Anaerobic sludge digestion. There are 4 key biological and chemical stage of anaerobic digestion, and now we have to concentrate on these 4 stages. That 4 steps that are very most important step are hydrolysis, acidogenesis, acetogenesis and methanogenesis. The first is hydrolysis. What exactly the hydrolysis? We know very well H2O breakdown is that 2H plus and oxygen is released. The same step is there. Why that is significant? Because we know about the sludge. The sludge contain heavy amount of the water, and that water removal, the thickening of the sludge is there by this particular step, that is we call it as hydrolysis. So first step, that is very most important step in anaerobic sludge digestion, that is hydrolysis. And by that the thickening is going to be there. That is one of the metabolic process of anaerobic bacteria, thermophilic bacteria, they are involved in anaerobic sludge digestion. The second step involved is acidogenesis. Acidogenesis. What is acidogenesis? Acid production. Now what is acid production? Acid production is the one when organism utilizes organic matter, and we call it that matter is, or what we call it, that particular thing, we call it fermentation. What is fermentation? Where electric organic donor and organic acceptor, electron donor and electron acceptor, both are organic one. That phenomena is known as fermentation. So many of the book even represents acidogenesis as fermentation. With the help of fermentation or with the help of acidogenesis, many of the organic matter that is present in the biodegradable waste, that is going to decomposed by the variety of thermophilic bacteria, variety of anaerobic bacteria. So that is second very most important step being processed by the organism. The third step is acetogenesis. Acetogenesis just have the role of acetone group. And the fourth most important is methanogenesis, or the production of methane gas, that we can see from the next figure. In the figure you can see the particular anaerobic sludge digester. Now this is the single stage is there, the one digester is there, but now there are double chambered anaerobic digesters are even available. This particular figure you can just see in the central area active digestion is there. The sludge is going to be collected from the base and the gas is collected from the topmost area. Even we can discuss this. This is the schematic diagram, but better explanation is there from the next figure. You can just see in this particular figure at the base mixing zone is there. Whatever the sludge is added, the solid part is added, that is there in the center area. The sludge zone is there. In this sludge zone, the thermophilic organism and anaerobic organism grow in such a way, acidogenesis, acetogenesis, hydrolysis occurs. Whatever the liquid is there, that is going to be less and less, and the sludge is prepared, the thickening is there, and even the degradation is there in such a way the methane gas is liberated, and the yellow portion at the topmost shows the biogas collection. So this is the anaerobic sludge digester. With the thick wall is there, here temperature, pH, all the thing is very much significant, and this now even this is there with the doubled chamber. So this is single chamber is there. Now even the double chambered anaerobic sludge digester are there with many of the wastewater treatment plant. Next please. Now we are coming to the last point, that is composting. What exactly the compost? After the anaerobic sludge digestion, after the treatment of solid, whatever we have with us, that is passed from the ultrafiltration, that is passed from the heat treatment, that is passed from the vacuum filtration and the vacuum whatever the collection is there. Because of that, the thick portion is there, the thick particles are there, that is rich in the organic matter, that is rich with the nutrient, and that we call it as compost. Now what is compost? Compost is soil conditioner. We know about the conditioner, there are variety of the conditioners are there. Soil conditioner is there, that we call it as compost, and that compost we can obtain from the wastewater treatment by the processing of the solid and by the anaerobic sludge digestion. So what is compost? Compost can be rich in nutrient. It is used in garden, landscaping, horticulture and agriculture. The compost itself is beneficial and in also applied in the land as a soil conditioner as well as as a fertilizer. So that is about the compost that we obtained by the solid processing. Next please. So this is overall summary of the wastewater treatment. First of all, what we have discussed in the whole wastewater treatment, we have discussed about the primary treatment, the secondary treatment, advanced treatment and then the solid processing. There are 4 basic steps. What exactly the first step is? The first step is primary treatment, where the coarse part are going to be removed, and in the secondary treatment the role of aerobic as well as anaerobic is there. Aerobic, it means whatever the process is that is being carried out in aerobic condition with the help of oxygen, while anaerobic is the one where no involvement of the organism is there, no involvement of anaerobic bacteria is there. So anaerobic and aerobic processes are there. We have discussed about the secondary treatment in which oxidation pond, forced aeration are involved. Then we have discussed about the advanced treatment. In the advanced treatment we have discussed chlorination, activated carbon and whatever the effluent is there that we can go we can apply it for the landfill, we can apply it for the waterways in the lake also, that can be applied, and whatever the solid is left that is applied for anaerobic sludge digestion, and compost can be prepared and that act as the solid conditioner. But all this thing is based on which type of the wastewater is there, how much volume of the wastewater is there, how many type of the toxic product is there in wastewater, and according to that we have to proceed for the process. We have to even consider in this particular method the unit that we are establishing as the wastewater treatment plant, which type of the instruments are available, which type of the area is available, and on that basis we can proceed for the treatment. So that is all about the wastewater treatment. I think any other thing you can say?
So friends, we can conclude that wastewater treatment is economically important, ethically important, legally important and socially important. How it is important economically? So we know that as ma'am has already discussed in their talk that we can get biogas or methane via this process. So we are facing the scarcity of fuel nowadays, particularly petroleum fuel and all the things. In this condition, biogas may be one of the best option for alternate fuel source. Methane, which is generated from this process, it can also used to generate electricity, and even some examples are also there at where entire plant's electricity is running from methane, which has been generated from their own plant. So we can reduce our own electric bill of wastewater treatment plant. So this is economic aspect. Even madam has already told that some lakes or ponds can also be created in which this water can be discharged at last. So some recreational activities can also be carried out, means some amusement park or some garden or many other things can be prepared in such places from at the end of wastewater treatment. So in this way we can say that it is economically important process. It is important ethically also, because it is our moral duty that we should not discharge such polluted polluted water or such wastewater in any natural water body directly. Otherwise it may harass or it may make an imbalance in natural or in aquatic ecosystem, and certain organisms may be extinct out due to our such activities. So it is our moral duty, or it is our ethical duty also to do this treatment. It is legally also, because there are so many environmental protection acts are also running, like GPCB, like government bodies are also running, like Gujarat Pollution Control Board or CPCB, Central Pollution Control Board. They are also looking after to such, they are also encouraging such activities for wastewater. So at last we can conclude that it is our economic, moral, social, legal, ethical, all this our duty, that water must be treated before discharging in any waste water. So friends, this is very important question. Almost some of the questions are compulsorily asked in exams from this part. It may be in full length question, it may be in some short notes, or it may be some objective questions may also be asked in the exam. So from exam point of view, it is also economic to earn some good marks in exam. So now if you have any doubts or queries, then you can ask.